Close your eyes for a second and imagine this. You are inside a spacecraft. Earth is shrinking behind you. Your destination is another planet. Your instinct tells you something very simple. Point the spacecraft at the planet and go straight. That instinct is wrong. Not a little wrong. Not technically wrong. Completely, fundamentally wrong. If you try to travel to another planet in a straight line, physics will punish you for it. You will waste absurd amounts of energy, miss your target by millions of kilometers, or never arrive at all. And the reason for this feels deeply uncomfortable because it goes against how our brains understand motion. The universe does not let you move freely. It makes you bless, and not metaphorically, literally. From the moment you leave Earth, physics begins to curve your path whether you want it or not. Here is the first thing that breaks human intuition. You are not standing still when you launch from Earth. You are already moving sideways around the sun at nearly 30 kilometers per second. That motion does not disappear just because your rocket engines fire. You carry it with you. So now imagine trying to reach another planet while already flying sideways at cosmic speed. You cannot cancel that motion without spending an impossible amount of energy. And you cannot ignore it either because gravity will not allow it. This is why space travel is not about going somewhere. It is about changing what you are orbiting. Right now, Earth is locked into a stable orbit around the sun. That orbit is an energy state. To reach another planet, you must move into a different energy state. You are not traveling across space like a car on a road. You are sliding between gravitational levels like an object rolling through valleys and hills. And this is where physics starts to drive you around the bend. Because the lowest energy path between two orbits is never a straight line. It is a curve, a long, slow, graceful arc that looks completely wrong to the human eye. When mission planners draw spacecraft trajectories, the paths look absurd. They spiral outward. They loop around planets. They dive closer to the sun before climbing away from it again. They look like mistakes, but every one of those bends exists for a reason. Gravity is not a force that simply pulls you down. It's space motion itself. Every massive object carves a curvature into space, and anything that moves nearby is forced to follow that curvature. You don't fight gravity in space. You ride it. Think of space not as empty, but as a landscape. The sun creates a deep gravitational valley. Planets create smaller valleys within it. Your spacecraft is like a marble rolling across that surface. If you try to push it straight uphill, you waste energy. If you let it roll along the contours, it goes further with less effort. This is why the shortest path is not the best path. This is why the fastest path is often the worst one. Human intuition wants speed. Physics wants efficiency, and efficiency demands curves. Here is a strange but true statement. Spacecraft do not go to other planets. They fall toward them, sideways, very slowly. Those sideways fall is what an orbit really is. Right now, Earth is falling toward the sun. It just keeps missing. That constant miss creates an orbit. When you leave Earth, you are still falling toward the sun. Still missing, but now in a slightly different way. To reach another planet, you must adjust how badly you miss. And that adjustment cannot be done with a straight push. Instead, spacecraft use what are called transfer orbits. These orbits gently reshape the spacecraft's path so that months later, the destination planet happens to be in exactly the same place at exactly the same time. That timing is everything because planets do not wait for you. Mars will not slow down because you are late. Jupiter will not pause because your trajectory was inefficient. If you arrive at the wrong time, there is nothing there to meet you but empty space. So mission design becomes a kind of cosmic choreography. You launch not when you are ready, but when the geometry of the solar system allows it. You aim not where the planet is, but where it will be, and you let gravity do most of the work. This is why interplanetary missions take months or years, not because space is hard to cross, but because fighting physics is too expensive. Now let's go further out. Suppose you want to travel to Jupiter or Saturn. These planets are not just destinations, they are gravitational giants. Their influence stretches millions of kilometers into space. If you approach them carelessly, they will capture you, fly you away, or tear your trajectory apart. But if you approach them precisely, they can become engines more powerful than any rocket you could build. This is where physics bends your path in the most dramatic way. A spacecraft can steal energy from a planet, not by touching it, not by landing on it, but by falling past it at just the right angle. As the spacecraft enters the planet's gravitational field, its path curves sharply. From the spacecraft's perspective, the planet pulls it forward and then releases it. From the sun's perspective, the spacecraft leaves with more energy than it arrived with. The planet loses a tiny amount of orbital energy. The spacecraft gains it. The exchange is so small, the planet never notices, but the spacecraft does. Its speed increases. Its orbit stretches. Its future changes. This maneuver forces the spacecraft into extreme curves that look insane on diagrams. It can approach a planet from behind, whip around it, and exit in a completely different direction. To the untrained eye, it looks like a detour. In reality, it is physics doing free work. And this reveals something profound. Space does not reward brute force. It rewards patience and precision. Every bend in a spacecraft's path is there because the universe refuses to be rushed. Energy must be conserved. Momentum must balance. If you try to ignore those rules, the universe doesn't argue with you. It simply lets you fail. This is why space travel feels so alien. On Earth, we overpower our environment. We flatten roads. We build bridges. We burn fuel to go where we want. In space, you cannot overpower gravity. You must negotiate with it. And gravity always demands a curve. Even if you turn off your engines entirely, your path will not be straightened. You will continue to bend, guided by invisible forces that have been shaping motion since the universe began. So when people ask why space agencies don't just fly straight to other planets, the real answer is this: straight lines are a luxury of friction and roads. The universe has neither. In space, everything moves. And if you want to travel between worlds, physics will take the wheel whether you like it or not. In the next part, we're going to push this idea to its limit and see how time, energy, and gravity together turn space travel into something that feels almost alive. And here is the part that quietly unsettles scientists the most. Even when everything goes right, even when the math is perfect, even when the engines fire exactly as planned, the spacecraft is never truly in control. After a certain point, it becomes a passenger. It is being driven. Driven by gradients of energy. Driven by invisible slopes carved into space. Driven by physics that does not care about intention. Once the engines shut down, the spacecraft does not stop moving forward. It doesn't stop moving sideways. It simply continues along the curve that gravity has already decided for it. At that moment, the path is no longer negotiable. It is inevitable. This is why mission planners obsess over decimals. A tiny error early in the journey does not stay tiny. It grows. It bends the bend. It shifts the curve just enough that months later, the destination is gone. Space is unforgiving not because it is hostile, but because it is precise. Every curve you see in a trajectory diagram is the result of conservation laws being obeyed perfectly. Momentum conserved. Angular momentum locked in place like a cosmic contract. And that contract cannot be broken. So physics does not just suggest a curved path. It enforces it. It corners you into it. It removes every alternative until only one motion remains possible. The bend is not optional. It is the price of moving at all. Once you truly understand this, space travel stops looking like exploration and starts looking like surrender. You are not conquering distance. You are yielding to structure. You are letting the universe decide how motion is allowed to happen. And paradoxically, that surrender is what makes interplanetary travel possible. The moment you stop trying to go straight, the universe opens pathways that were invisible before. Paths that are longer in distance, slower in time, but infinitely cheaper in energy. That is the final insult to human intuition. The universe rewards those who bless. Now let's take this understanding and push it to a place where it becomes genuinely uncomfortable. Because once you accept that space travel is about bending instead of going straight, a deeper realization starts to form. One that quietly rewires how you think about distance, control, and even time itself. In everyday life, distance feels absolute. 10 kilometers is always 10 kilometers. An hour is always an hour. You move faster, you arrive sooner, you burn more fuel, you overpower the road. In space, distance is almost meaningless. What matters is how deep you are in a gravitational well and how much energy it takes to climb out of it. Leaving Earth is not about escaping Earth, it's about escaping Earth's energy, and that energy barrier is enormous. Most of the fuel used in a space mission is spent in the first few minutes after launch. Not to go far, but to change the spacecraft's relationship with gravity, to lift it into a new energy state where other paths become possible. Once that is done, the rest of the journey becomes strangely passive. The spacecraft coasts, it drifts, it waits. This waiting feels wrong to humans. We associate motion with effort, but in space, effort is front-loaded. The rest is geometry. You are not racing toward another planet. You are waiting for the solar system to rotate into the right configuration around you. This is why launch windows exist. If you miss them, you don't just delay your trip by a few days. You delay it by months or years. Because the bend you need no longer lines up. The universe does not give you infinite chances. It gives you brief alignments, and when you catch one, you ride it like a wave. This also explains something else that feels deeply unintuitive. Sometimes, to go farther out, spacecraft first fall inward. They move closer to the sun. From a human perspective, this feels backwards. Why move away from your destination? Why dive deeper into gravity when you want to escape it? Because energy is relative. By falling inward, the spacecraft gains speed. That speed can then be redirected outward into a higher orbit. The path bends inward before it bends outward, like pulling back a slingshot before release. Once again, the universe insists on curves. Now let's talk about time. From inside the spacecraft, nothing dramatic is happening. There is no sensation of acceleration for most of the journey. No feeling of speed. The stars barely shift, but from the outside, time stretches. Months pass, years pass. This is another quiet consequence of efficient paths. The least energy-hungry routes are slow. They trade time for fuel. And time in space is negotiable. If you are willing to wait, gravity will do astonishing things for free. It will bend your path perfectly. It will deliver you to places no engine alone could reach. This is why probes sent to the outer solar system often take decades. Not because we lack power, but because we choose patience over waste. And patience is rewarded with precision. Every successful interplanetary mission is a victory of humility over force. Now consider something even stranger. Once a spacecraft leaves Earth, there is no continuous control. Commands take minutes or hours to arrive. By the time you correct an error, the error has already evolved. This means most of the journey is pre-written. You don't steer in real time. You commit. You lock yourself into a curve and trust the math. That trust is not blind faith. It is earned through centuries of physics. But emotionally, it feels terrifying. You launch something fragile into an environment where you cannot intervene, and you rely on invisible forces to carry it safely across millions of kilometers. And those forces do not care if you are watching. This is where the phrase drives you around the bend takes on its full meaning. Physics does not ask permission. It does not compromise. It does not adjust to preference. If you want to travel to other planets, you must submit to the shape of motion itself. You must let gravity turn you. You must let energy dictate your options. You must let time stretch. The bend is not just physical, it is psychological. It forces you to abandon the idea of directness, to accept that progress sometimes means moving sideways, backward, or nowhere at all for long stretches. And this lesson extends beyond space. The same equations that guide spacecraft also govern moons, rings, asteroids, and galaxies. Everything that moves on large scales follows curves carved by mass and energy. Straight lines are rare in the universe. They exist only in the absence of influence. And influence is everywhere. This is why even light bends. This is why stars orbit invisible centers. This is why the universe looks the way it does. Once you truly internalize this, space travel stops being mysterious. It becomes inevitable. There is only one way motion can work when everything pulls on everything else, and that way is curved. So the next time you see a diagram of a spacecraft looping wildly through space, remember that you are not seeing complexity for its own sake. You are seeing simplicity expressed honestly. Physics is not being cruel. It is being consistent. It is saying this is how motion survives. And the price of survival is bending. To reach other worlds, you don't conquer space. You align with it, and in return, the universe opens a path that no intuition could ever design. That is how physics drives you around the bend, not to confuse you, not to mock you, but because there was never any other way to go.